Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem binary tree to CDLL. So this is a medium level problem and it's the problem of the day on Geeks for Geeks. So this question has been asked by the companies Amazon and SAP Labs and also IBM as well. And the topic tags are linked list tree data structure. So let us go through the question now. Given a binary tree of n edges, the task is to convert this to a circular doubly linked list. So if you're not sure about this, please go to Google, go to search about this circular doubly linked list. You'll find a lot of articles, even in Geeks for Geeks. Just go through them, you'll get a better understanding for sure. So the left and right pointers in nodes are to be used as previous and next pointers respectively in CDLL. So I'm again stressing on this fact. Make sure you're going through the CDLL before you start solving this question, because if you're not sure about CDLL, this is not going to, it's pretty hard to solve this question because you need to understand those concepts. So the order of nodes in CDLL must be same as the in order of the given binary tree. It's been clearly mentioned here, so need not trouble yourself by thinking what should be the order of in order of the nodes in CDLL. It must be the same as the in order. So what is in order? In order is left, node, right. Okay, LNR. So just remember that. So if they are asking about the in order traversal, just make sure you're first doing on your left and then yourself and then to your right. Let you assume you are the node of the tree, do it on your left and then on yourself and your right, the traversal that I'm talking about. So the first node of in order traversal must be the head node of the CDL, and it will be the leftmost node in the BT, isn't it? So because they are asking us to do the in order traversal, so what will be the first node in the in order traversal? The leftmost node, isn't it? And that must be the head of the CDLL, because it's clearly mentioned the order of nodes in CDLL must be same as the in order in the given binary tree. I hope you understood. Like, we'll solve it. We'll even go through the examples that have been given and we'll solve it. And the constants are n goes up to 10 power 3 and data of node goes to 10 power 4. This really does not matter. Yeah, n matters because we need to figure it out. So I'm using the same thing. Expected time complexity is O of n. I'm visiting all the nodes via recursion, and that auxiliary space, I'm not using any auxiliary space. Like in our solution doesn't use any auxiliary space. It's just that we are constructing the required CDL. And yes, so now let us go through the examples. So this is the first example that has been given, 1 3 2, right? 1 3 2 1 3 2, like this is the binary tree that has been given, 1 3 2. So when you're asked about to do the in order traversal, what do you do when you asked about the in order traversal? How do you write it? It's first you write the leftmost, that is 3, and then your node, that is 1, and then your right, that is 2, right? Now convert this into a CDLL. How do you convert this into a CDLL? First write them as nodes. Let us like the square denotes the node, okay, which has left pointer, right pointer, the same thing as a tree. So 1 and 2. So initially connect these two, okay, 3 1, we connect like this. And now because it's a CDLL in the sense compared to a normal linked list, CDLL have a previous pointer as well. All right, previous pointer as well. In normal linked list, we just have the next pointer or the right pointer, you would say. But here we have the previous pointer or left pointer. So when for 3 there is a pointer here, what will you do it? Because it is a circular, you will be pointing this to the last most and like the final most node. All right, this is what you'll be doing. You'll be actually pointing it to the last one. What is the last one? This is. So this fashion there is a circle being formed, but at the same time even 2 has a left node, right? Now 3, we have satisfied the left pointer of 3, so left pointer of 3 connects with 2 and right pointer connects with 1. But what about left pointer of 1 and 2? So in this fashion we'll also connect the same way. So 1 and 3 will be connected like this, 2 and 1 will be connected like this, and also now we have the right pointer of 2 that must be satisfied. Left pointer got satisfied of 2. What about right pointer? In that we'll be doing like this. All right, so if I need to put that in this particular fashion, like if I write each and every node as 3 components, like so this is 3 and this is 2, this is 1, and for 1 it looks like this. So 1 has 2, 1 will be the middle, and to the left it will be pointing to 3, to the right it will be pointing to 2, and for the 2 it will be in the middle, and to the left it is pointing to 1, to the right it's pointing to 3. Okay, I hope you people understood. So this is how it appears. So this is a CDLL. All right, I hope you people have understood what is a CDLL, how are we doing it, how are we representing it. So I'm stressing on this fact again. Please go through CDLL if you do not know about this thing particularly. So this is done. So that is the reason the answer is 312 or 213. Like all of these the same thing because it's circular. So either you start from here or start from here, doesn't make sense. You'll be ending up with the same pattern. And 312, it's evident because it's the in order they're asking about. So in order, what is the in order? 312, right? So that is what you'll be giving out as output. And coming to this particular thing, 10 20 30 40 60. So what is the in order for this? In order is that's been given in the output, that is 40 20 60 10 30. But how do we represent this as in the CDLL? So just take this as 40, okay, just take this 40 node, 20 node, 60 node, 10 node, 30 node. Okay, so how do I connect this? So I'll just write the first right pointers, okay, right pointers, and now also do the left pointers as well, satisfy this left pointers as well. Now what are the two things that haven't been satisfied? 40 is left and 30 is right. So to satisfy 40 is left, connect this to with the right. Okay, connect this with the 30, and to satisfy 30 is right, connect this with the 40. Okay, so this is how we'll be doing the circular thing. I hope you people understood. So first write the left and right for each of the nodes in between, satisfy all of them, all of these in the between, and for the end points that have not been satisfied, connect them. So this is how you can construct the CDLL in a much intuitive way and without any sort of confusion. So now we need to frame the approach. I hope you people understood how are we presenting this CDLL. Now we need to frame the approach on how are we going to get this particular thing. Okay, let me erase this part. See, whenever there's something like this has been given, so it would be foolish if you try to solve for each and every node, isn't it? Now let us take this particular example. We have 10, 20, I'll just write this here, 10, 20, 30, 40, 60. Okay, so we have 10 here, 20 here, 30 here, and 40 here, and 60 here, and let us assume I have 70 here as well. Okay, now if I try to do this whatever thing that I'm trying to do, like whatever conversion that I'm trying to do, if I try to do that on each and every particular node, then I'll be a most foolish person, right? I must not do it individual on myself. I shouldn't go and check it for everything. Rather, I need to give these parts to the recursion. So what I'll be doing is I'll be doing only on myself. Let us assume you're standing on 10. Okay, you're standing on 10. You'll only be doing to yourself. What you'll be doing to yourself, you'll be converting all of this into a CDLL. You'll be converting, like you'll be telling the recursion to do this particular thing, task. What is the task that you'll be asking your recursion to do? Convert my left side to CDLL, convert my right side to CDLL, and give those pointers to me. Then I'll be putting my left of this to this, right of this to this. This is what I'll be telling. All right, this is what I'll be telling to my recursion. What will I tell to my recursion? I'll be telling to my recursion that you convert this left one, the whole left subtree of mine, to some CDLL, and convert my right side of mine to some CDLL, and give those pointers. Now I'll be keeping my left to left CDLL, right to right CDLL, and then I'll be returning the left CDLL head, because what are we going to do? We are going to put the CDLL in the in-order traversal way. If you are doing like in-order traversal, your leftmost node must appear at the first. All right, so that is the reason for you'll be returning at the end the left head. Okay, left CDLL head. So how are we doing this? So this is the task. Okay, and you'll be leaving it to the like recursion to work on this left subtrees and right subtrees. You'll only be working on your node. The rest of the task you'll be leaving it to the recursion. So how are we going to do it? So I'll just erase these particular points first. Okay, so first, how do I convert this particular thing? Like let us assume now we are on 10. Now we have given the task to left and right. Now giving task in the sense you need to clearly describe how are you doing it. So that we need to see now. And once you are on 20, okay. Now once you are on 20, okay, because first you are at 10. Now we have given the called the recursion to do on left and right. Now you are on left. Okay. Now again you are on 40. Okay. Now again you are on 40. So now because when you are on 20 you called for left and right. Now your left is 40. Now here 40. How are you going to convert this into a link CDLL? So because 40 as no left, no right, 40 as no left and no right, what I'll be doing is I'll be taking a node 40 and I'll be connecting its left to itself and its right to itself. Okay, I'll be connecting its left to itself and right to itself, because there's nothing like left child and right child for 40, right? There's nothing like that. So that's the reason I'll be pointing my previous pointer. That this is previous pointer, this is next pointer. We are talking in terms of CDLL. Okay, we are talking in terms of CDLL. So this individual 40 is a CDLL. Okay, where its previous pointer is pointing to itself and its next pointer is pointing to itself. And when you're calling on this particular 60, the same thing happens. Even for 60, we have no left child and no right child. So its previous pointer will be pointing to itself, its next pointer will be pointing to itself, right? So this is what it happens. Now when you come to 20, 20 has both its left and right. So when after finishing these two calls, I'll be getting back to 20. So I see, because now I find a CDLL in my left, and I find a CDLL in my right. So how am I going to connect these two? So I have a CDLL like this, right? I have a CDLL like this 40 I have. So its previous and its next is pointing like this. Now I have a 20 that I need to convert this into a CDLL, and even I have a 60. Like this is how it's pointing, right? Left and right of 60 is pointing to itself. Now how do I make this into a CDLL? So the first step that I'll be doing is I'll be putting this 40's right to 20, isn't it? 40's right, 40's next. Okay, let us talk in terms of CDLL. 40's next would be 20, and see this particular 60's left would be this particular thing, isn't it? 60's left or 60's previous. 60's previous. No, sorry, this is not how it looks. So 20's next. Okay, 20's next would be 60. And now 40's. Okay, 40's. We are trying to convert this whole thing into a CDLL. Okay, remember that. Now 40's. 40's next has been satisfied. What is yet to be satisfied? 40's previous. Now 40's previous would be pointing to 60. Okay, 40's previous would be pointing to 60. And still what is yet to be satisfied? So we have satisfied 20's next, and 20's left. What is 20's left? 20's left would be 40. Okay, 20's left would be 40. 20 is completely satisfied. 20 is completely satisfied. And 40's next. 40's next is 20. 40's previous. Previous is 60. Even we have satisfied with 40. Now only thing that's left is with 60. So 60's left. 60's left or previous. Okay, 60's previous would be 20. So 60's previous is also done. Now 60's next. So 60's next would be pointing to 40, right? So even 60, we have done this particular thing. We have solved it for a particular thing. Please go through the video once again. All right, we are just trying to connect these things. If not, I'll just try to put this thing again. So initially we are having like this. So we have got the 40s and 60s sorted initially. Now we are trying to include 20 in their family, like we are trying to join these two. Let us assume this is a husband, 40s husband, 60s wife, and 20 is the child. Okay, 20 is the child. So we are trying to reunite them. Once they were united, now they are diverse. Now we are trying to again join them. So how are we going to join them? That is the thing, logic. So now 40 is only pointing to itself, 60 is also pointing to itself, both left, previous and next. Now 20 we are trying to put in between them. How are we going to do? The first step that we are going to do is 40s. Okay, 40s next I'll be pointing to 20. Okay, 20s next I'll be pointing to 60. So 20s, this is how it will be. And now 20s previous would be 40, 60 previous would be 20. So in this fashion we have connected 20 to 40 and 60 completely. Okay, completely we have satisfied. 20s previous is also satisfied, 20s next is also satisfied. Now coming to 40, how are we going to satisfy 40? So 40s next is satisfied, it is with 20. What would be 40s previous then? Connected with 60. Okay, now 40 is also completely satisfied. 40s next is 20, 40s previous is 60. Now coming to 60, how are we going to satisfy? 60s previous is 40, 60s previous is done, 60s next is 40. Okay, 60s next is 40. So in this fashion we have even satisfied with 60. So if we represent this in much better way, we can find like this. So 40 here, and for its previous would be 60, its next is 20. And for 20 we have previous to be 40 and its next to be 60. And for 60 the previous is 20 and the next is 40. I hope the people understood. So this is how we have converted. And now what are we going to return? This is what we are going to return, because this is what we dealing with. This is what we need to return at the end of the day. All right, because in order we are going to return, and in order this is the first node. Okay, 40 would be the first node. So when coming to so now this whole thing is satisfied. Now this whole thing is satisfied. So how 10 see this particular thing? 10 see this? How does 10 see this? So I'm looking for a best place to write this. So I'll just erase this particular thing. Okay. So how does 10 see this? So for 10 looks to its left and see like there's a CDLL coming in this fashion: 40, 20, 60, and this fashion, and this. Okay, and so this is satisfied, and this. All right, so 10 sees this. Okay, to my left a CDLL has been formed, and now I need to be a part of the CDLL. How am I going to be a part of the CDLL? Apply the same logic. So what are the 4 transitions that I'm going to do? So let us assume my 10 is here. Okay, my 10 is here. What are the 4 transitions that I'm going to do? First transition is I'll be connecting this 60 with 10, right? I'll be connecting this 60 with 10. So 60 is next. 60 is next would be 10. This is the first transition that I'll be going to do. And I'll just erase even this, or let us write that without any confusion. So okay, so this is how it is. Okay, I hope you people understood. So 60's next would be 10. That is the first transition that I'm going to do. 10's left would be 60. Okay, 10's left would be left or previous. Okay, 10's previous would be 60. This is the second transition that we are going to do. And now we have to connect 40 and 10, because the last node is no more 60. It is 10 now. Now I need to connect 40 and 10. How am I going to connect 40 and 10? Just remove these two. So 40's next, or 40's next would be pointing to 10. 40's next would be pointing to 10. This is third. And now also 10's next, sorry, 40's this is previous, right? So please do not confuse, like previous, this is previous, 40's previous, this is the third transition, and 10's, okay, 10's next would be 40. So this is 4th transition. So there are total of 4 transitions that I'm doing. Change these particular 2, like connect these particular 2 and connect the first, that is 40, and the new last member, that is 10. So this is how we are doing it. I hope you people understood. So there are total of 4 transitions that we are doing. Just remember those transitions and apply the same logic everywhere. So 10 and left has also been connected. Now how are these two connected? After, like when we call on 30, these two will be connected in this fashion: 30, 70. So this and this, right? This is how they are connected. Now there are 2 CDLL. This is CDLL, this is CDLL2, and this whole thing is CDLL1. So how are we going to connect them? Let us see that now. So I'll just erase this part. Oh, sorry. I'll just erase this particular thing. Okay. So what are the 2 CDLLs that we have now? So we have 40, we have 20, we have 60, we have 10, and this is connected in this fashion. And okay. So fine. So this is connected in this fashion. And what's the other CDLL that we have? 30 and 70. 30 and 70. All right, 30 and 70. And okay, all right. Now we need to connect these two. Again, what are the 4 transitions? Whenever you're trying to connect 2 CDLLs, only 4 transitions are there. Connect these two. All right. So your 10's next would be no more 40. It would be 30. All right. So let us erase this part. So 10's next. That is your first transition. And 30's previous. Okay, this is 30's previous. So 30's previous. So 30's previous in the sense this would be, yeah, 30's previous. 30's previous would be your 10. This is the second transition that you're going to do. Now you are going to connect the 70 and 40. How are you going to connect 70 and 40? 40's next would be no more 10. It would be 70, right? 40's next 40s next would be 70, right? 40s next would be 70. This is third transition. And now 70s, sorry, 40s previous. So I'm always getting confused, like 40s previous. It's not next. Previous in the sense right. So previous in the sense left and next in the sense right. So please don't confuse. I'm getting confused at this point. So previous is third transition that I'm going to do. And what's the other transition? 70 and 40s. 70s next should be connected with 40. So I'll just erase this particular point. So 70s next would be 40. Okay, 70s next would be 40. So this is the 4 transitions. So these are the 4 transitions that I'm going to do. And at the end of the day, my CDLL will be looking like this: 40, 20, 60, 10, 30, 70, and now going to connect right, and this right, and left, left. All right. So in this fashion, we have connected everything possible. And also I need to connect this particular thing. All right. So in this fashion, we have connected everything. I hope you people understood how are we doing actually. How are we framing this? It's like the basic CDLL concepts that we are using, trying to do 4 transitions and then mix it up and then complete it up. Okay. So that's what we have done here. Let us go through the code. Firstly, I'm calling the recursion on my left tree, on my right tree. Okay, left CDLL, like left linked list that I'm going to get, and right linked list that I'm going to get. And initially, my root, my node that I'm standing on, my left and right pointer would be pointing on myself itself. So now I'm going to concatenate the left CDLL and myself. Okay, what are the first step that we are going to do? Left CDLL plus myself, and then after getting this, let us assume this is complete left. Okay, this is complete left. Now left plus right CDLL, okay, and now after these 2 transitions, we are going to return the left CDLL. Okay, left CDLL, or if I mention this to be some right, or whatever you can name it. So because this right would be pointing the will be having this particular start itself. Okay, the whole CDLL starting point, the head point only will be having the right. So we'll be returning the right. That is the reason I've written right half here. So left half, do not go with the words. I've messed up over there. So root left and root right equal to root pointing myself both left and right, and left half I'm concatenating my left CDLL with root, and then right half would be concatenating the whole left that we have got, that is left half, with the right CDLL that we have, and finally returning this right half. I should have named it something else, but yeah, it's fine. So how are we going to concatenate? If your left CDLL, if it's null, only return your present CDLL. Okay, for example, when you're doing this particular thing, when you're working on 40, there's nothing like left, so only return yourself, right? Only return yourself. So, and when your present CDLL is not defined, or if it's none, then return left CDLL. All right. So now we are doing the 4 transitions. So if you carefully observe, what are the 4 transitions that we are doing? First transition, second transition, third transition, fourth transition. Okay. So left end is what we are first trying to find. So if we actually just try to take this as a reference. So I'll put this here. Okay, I'll put this here, and I'll even erase this part. Okay, I'll just move this to, okay, fine. Okay, so if you carefully observe, what's the first transition that we are doing? Like my left end, firstly I'm finding the left end. How do I find this particular 10? So this is what I'm finding, right? First I'm trying to do a link between 10 and 30. How am I going to find the 10? Initially 40 and 10 are connected. How are they connected? 40's left is equal to 10. So that is the reason left end is basically left CDLL ka left, or left CDLL ka previous. So its previous or left would be 10. All right. And now what is the right end? What is the right end? Right end is present CDLL ka left. So initially how do we get 70? So 70 is 30's left, isn't it? So 30's left or previous is 70, isn't it? Both of these are same thing, left or previous. So initially 30's left is 70. So now are we going to connect left and right would be your left left and right would be your present CDLL. Your present CDLL 30. So I'm connecting this 10 and 30. So left CDLL correct. So 10's next or right would be 30. That's the first transition that we are doing. And present CDLL left would be right hand. So 30's left would be 10. So this is the second transition that we are doing. Okay. 10's right would be 10's right or next would be 30, and 30's left or previous would be 10. We are done with this successful transition. We are done with this transition successfully. Now we need to connect this 40 and 70. How are we going to do it? Left end CDLL left would be right end, isn't it? Because this is right end. We are going to connect this left end left CDLL previous with this, and then right end left means the like right hand left would be this right hand's right in the sense this right would be left CDLL. This is particularly 40. So in this fashion we have connected the whole CDLL, we have made the whole CDLL, and finally returning left CDLL because we are interested in this particular point itself. So that's the reason we are returning it. I hope you people understood what are the 4 transitions that we are doing. It might be confusing at the very first instance, but if you go through the video once again, you'll get a better clarity, and write this on paper. Solve this on paper, you'll be getting much more better clarity, and definitely you'll be able to solve it on your own for sure. Okay, write it on paper. What are the transactions that we are doing? What are the changes that we are doing? You'll definitely understand this funda logic. Okay. So I hope you people understood. So this is it for today, and the codes in C++, Java, Python are given in the description. Please go through them, and if there are any doubts, please feel free to comment in the comment section. I have put my best here. I've tried to put my best. I've put the optimal code, most optimal code. I've explained the most simplest solution ever. Just by the recursion, we are able to solve this question. Even this video might be lengthy, I'm sure about it, but still this is going to help you clear a lot of concepts, a lot of your concepts. Okay. So thank you for watching, guys. Stay tuned.